So section 3.1 of geometry is on lines and angles, pairs of lines and angles. We're talking about parallel lines and parallel planes, skew lines, what a transversal is, corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. So all those vocabulary words will be hit on. So first we have definition of parallel lines. Parallel lines are coplanar lines that don't intersect. So here we have line M and line N, both depicted by a lowercase letter. And our symbols, M is parallel to N, so the little symbols of the two lines going upward means parallel lines. So line M is parallel to line N. Also, the red arrows are also a signal or a symbol that show that the lines are parallel. Now, how does this differ from the picture below? Well, line P and line Q are skew lines. Skew lines are the same as parallel lines that they don't intersect, but skew lines are different than parallel lines that they are in different planes. And that's what this picture depicts right here. You'll note that we have a dotted line here behind the picture of the plane that indicates it's behind. Parallel planes are planes that don't intersect. And if we have objects within those planes, those can be parallel to the other plane too. So here we have line M and line K in plane P, and we have line N intersecting line K in plane P. You can tell now, since we have those blue arrows on line M and line K, that those lines are parallel within the plane. And we could say that line M is parallel to line K. Line M is skew to line N, and the question is, can a plane and a line be parallel? Can a plane and a line be parallel? So is plane Q parallel to line M? And the answer is, yeah, a line and a plane can be parallel since line M is in plane P and plane P is parallel to plane Q. We have a plane and a line that are parallel. So two lines that are in the same plane are either parallel or they will intersect in one point. And if a line intersects, two lines intersect in a point, then that line is going to be called a transversal. So line T here is a transversal for lines M and lines N. It looks like line M and N are not parallel, so we'd also expect that eventually lines M and N might even intersect. Here's a postulate. Through any point outside a line, there's exactly one line that's parallel. So here we have point P, and point P is not on line K. There is only one line that will go through point P that is parallel to line K, just one. And that's a postulate. Now, so if it's a postulate, got to understand that a postulate is something that is accepted without proof. So that's what we have here. Postulate accepted without proof. Again, we have our symbols. The red arrows indicate that the lines are parallel. If you have a point outside a line, there's only one line perpendicular through that point. And again, that's a postulate. We can't prove it, but we actually can construct it. Note the symbol over to the right here. It says T is perpendicular to K. The perpendicular symbol is an upside down T, upside down capital T. More vocabulary. So we have special angle pairs. Angles 1 and 5 are called corresponding angles. So there's more than one set of corresponding angles in this picture. Angle 3 would of course correspond with which angle? Angle 7. Angle 2 would correspond with angle 6. And angle 4 and angle 8 would correspond. Alternate interior angles are angles that are between the two lines that are cut by the transversal. So line R and line S are the lines, and transversal T is the transversal. So angle 3 and angle 6 are alternate interior angles. They're interior because they're between the two lines. The other set of alternate interior angles in this picture would be 4 and 5. Alternate exterior angles are outside of the two lines that are cut by the transversal. And 2 and 7 are alternate exterior, so you can also see that 1 and 8 would be alternate exterior. Consecutive interior angles are, again, between the two lines that are cut by the transversal, and they're on the same side as the transversal. So 4 and 6 are consecutive interior angles, as are 3 and 5.